What if I told you there's a battery that never degrades, never catches fire, never needs replacing, and some engineers are calling it the end-of-the-home battery as we know it? It's not lithium. It's not lead acid. It's a giant spinning wheel. And a growing number of off-grid, tiny home builders think it could change everything about how we store solar power. Today, we're breaking down Flywheel energy storage, what it actually costs in 2026, and whether it can really replace a battery bank in your tiny home. Stick around, because the ending of this video might completely change what you buy next. Before we get into it, hit that subscribe button and turn on notifications. We post new tiny home and off-grid breakdowns every week, and if you're serious about going affordable and self-sufficient, this channel is where you want to be. Every tiny home owner who goes off-grid runs into the same wall eventually. Solar panels are cheap now. Batteries are still the expensive, fragile part of the system. A complete lithium iron phosphate battery system for a tiny home, something in the 10 to 15 kilowatt hour range, is going to cost you anywhere from $3,500 to $8,000 once you account for the battery management system, built-in heating circuits, and professional installation. Interestingly, the raw battery cells themselves have dropped to somewhere around $150 to $250 per kilowatt hour at wholesale, but by the time you buy a finished, safe, wall-mounted residential unit, most of that savings gets absorbed by everything else in the system. And even the best lithium batteries lose capacity over time, hate extreme cold, and eventually need replacing after 10 to 15 years. So when word started spreading about Flywheel energy storage moving into the residential space, a lot of off-grid builders got excited. The pitch sounds almost too good. No chemicals, no degradation, no fire risk, a wheel that just spins. Here's the basic idea. Instead of storing energy in a chemical reaction like a lithium battery does, a flywheel stores energy as motion. You spin a heavy rotor up to extremely high speed inside a sealed, near vacuum chamber. When you need power, that spinning mass is connected to a generator, and the kinetic energy gets converted back into electricity as the wheel slows down. Now here's a detail that most videos on this topic get wrong, so let's get it right. Not every flywheel spins on magnetic levitation. High-end systems from companies like Amber Kinetics, Netiq, and Taurus use full magnetic levitation, where the rotor floats and barely touches anything, which keeps friction losses extremely low. But some of the more affordable residential designs, like the concrete flywheel we're about to look at, skip that expensive technology entirely. Instead, they use standard ball bearings combined with a passive magnetic thrust bearing that carries the vertical weight of the rotor, along with specialized vacuum lubricants to cut down on wear. It's a deliberate trade-off, giving up a bit of efficiency in exchange for a dramatically lower price tag. Because there's no chemical process involved, a flywheel does not degrade the way a battery does. Day 1 performance and year 20 performance are basically the same. Companies building these systems today are advertising lifespans measured in tens of thousands of charge cycles rather than the 1,000 to 3,000 cycles you get out of a typical lithium battery. Round-trip efficiency on modern flywheels is landing in the 85 to 90% range, which is genuinely competitive with lithium. This is not science fiction. There are real companies putting real money into this right now. A French company called Energy Estro has been installing concrete flywheel systems designed specifically for residential solar. Their flagship model, the VOS 12, delivers 7.5 kilowatts of power output with 12 kilowatt hours of usable storage capacity. The rotor itself weighs about 10 tons, and the whole unit is designed to sit on an outdoor concrete pad or be partially buried in the yard. Using concrete instead of expensive steel or carbon fiber for the rotor is exactly how Energy Estro keeps costs down while still backing the system with a 30-year guarantee, with the only expected maintenance being an inverter replacement around year 15. In the United States, the picture looks a little different. A startup called Netiq is developing large-scale flywheel rotors, but their target market is utility-scale storage, with flagship module concepts aiming for around 2,000 kilowatt hours of capacity. That is not a product a tiny homeowner could buy or install. It is built for power grids, not backyards. Taurus and Amber Kinetics are also playing in that commercial and grid-scale space, building hybrid flywheel and battery systems designed to smooth out sudden, high-power demand spikes for businesses and utilities. So here's the honest map of the industry right now. Grid-scale and commercial flywheel technology is advancing fast and is genuinely impressive. Residential flywheel technology exists, but it's essentially one company, Energy Estro, with one product line, and it is not yet a mainstream, widely available option the way a lithium battery wall is. Let's lay out why this idea has so much momentum behind it, because the argument is genuinely strong on paper. First, longevity. A flywheel rated for tens of thousands of cycles with minimal degradation could, in theory, outlast the tiny home itself. If you're not replacing a battery bank every 10 to 15 years, that's thousands of dollars saved over the lifespan of your build. Second, safety. There is no thermal runaway risk with a flywheel. No fire, no toxic off-gassing, nothing to vent. For a tiny home where your battery bank might be sitting a few feet from where you sleep, that peace of mind matters. Third, cold weather performance. Lithium batteries lose usable capacity in freezing temperatures, which is a real problem for tiny homes in places like Montana, upstate New York, or northern Canada. A mechanical flywheel does not care about ambient temperature the way a chemical battery does. Fourth, disposal. At the end of life, a flywheel is mostly recyclable steel, concrete, and copper windings. No toxic battery chemicals to deal with, no hazardous waste disposal fees. On paper, this looks like the dream upgrade for anyone building an off-grid tiny home in 2026. Now here's where we need to slow down, because this is the part that gets left out of most of the hype videos on this topic, and it's the reason I'm not telling you to go rip out your battery bank today. Flywheels lose energy just sitting there. It's called standby loss. And even with the best bearing designs, a spinning wheel is never perfectly frictionless. On a vacuum flywheel, parasitic loads like the vacuum pump, the magnetic thrust bearing, and residual drag typically eat up somewhere between 1% and 2% of the stored energy every single hour, whether you use any of that power or not. Let's do the math together, because this is the number that actually matters for a tiny home. Say you fully charge your flywheel at 4 in the afternoon after a sunny day, and you don't touch that stored power again until 7 the next morning. That's 15 hours of standing by. At even a conservative 1.5% loss per hour, you could lose somewhere between 15 and 25% of your stored charge before you ever flip a light switch. Now stretch that out across a full week of typical tiny home use. Some cloudy days, some sunny days, power sitting idle overnight every single night, and those losses compound fast. A lithium battery, by comparison, loses less than 0.1% of its charge per day sitting idle. Over that same week, your lithium bank has barely moved. Your flywheel has been quietly bleeding energy the entire time. That single fact tells you almost everything about why flywheels haven't taken over home solar storage yet. Industrial flywheel systems like the ones Taurus builds are designed for applications where you're charging and discharging constantly, sometimes multiple times a minute, for things like grid frequency regulation. Standby loss barely matters there, because the wheel is rarely sitting idle. But a tiny home needs the opposite. You need to store solar power for hours at a stretch and have it still be there when you need it. That is precisely the scenario where a flywheel's standby losses work against you the most. Then there's cost per usable kilowatt hour, and this is the number that matters most for your wallet. Even with Energy Estro's cost-conscious concrete design, a 12 kilowatt hour VOS 12 unit still lands well above what you'd pay for an equivalent lithium iron phosphate battery bank, once you compare usable, all-in capacity. Independent engineering analysis published this year, modeling flywheels against lithium for isolated, off-grid style systems, found that flywheels would need their cost to drop several times over just to become competitive for exactly this kind of long-duration, daily cycling use. Lithium costs have kept falling every year, which only widens that gap further. So here is the honest reveal. As of 2026, flywheel energy storage is not a drop-in, $0 replacement for your tiny home battery bank. The technology genuinely shines in a completely different lane, stabilizing power grids, smoothing out sudden demand spikes, and handling rapid fire charge and discharge cycles that would wear a chemical battery down in a few years. That is an incredible use of the technology. It is just not your tiny home's overnight power supply, at least not yet. If you've made it this far, you might be wondering whether it's even worth looking into a residential flywheel like the VOS 12 for your build today. Here's my honest take. If you're building a fully off-grid tiny home and your top priority is daily solar storage that will actually be there for you at night, lithium iron phosphate is still the smarter dollar for dollar choice in 2026. It's cheaper per usable kilowatt hour, it holds a charge far longer while sitting idle, and it's widely available with mature installation support. Where a flywheel genuinely starts to make sense is if you value the 30-year lifespan over minimizing upfront cost. If you're in a region with severe cold that hammers lithium performance, or if fire risk near your living space is a serious concern for you. In those specific cases, a product like the VOS 12 could be worth the premium, even knowing you'll lose some energy to standby loss along the way. If you're building off-grid in 2026, the smartest move isn't necessarily choosing a flywheel instead of a battery. It's understanding where each technology actually earns its keep. Your lithium battery bank stays the workhorse for daily solar storage because it's cheaper per kilowatt hour and holds a charge for as long as you need it to. If your tiny home runs power tools, a well pump, or anything with a sudden startup surge, a small flywheel paired with your battery system, similar to what Taurus is doing commercially, could absorb that spike and protect your battery bank from the kind of hard cycling that shortens its lifespan. That hybrid approach, battery for storage, flywheel for the sudden punches of demand, is where this technology is genuinely headed for smaller scale off-grid use. Not a replacement, a teammate. Flywheel technology is moving fast, and residential scale systems are getting cheaper every year. So this is a space worth watching closely. If Energy Estro or another company drops a genuinely affordable, low standby loss flywheel built specifically for tiny homes, you'll see it broken down right here first. Subscribe, turn on notifications, and drop a comment telling me what off-grid tech you want us to fact-check next. Thanks for watching, and I'll see you in the next one.